Okay, here is the first of 3 experiments dealing with the concept of bridges. This is Bridges 1. And it's looking at a very simple concept. We're looking at how this ruler, which is in effect our bridge, is deflecting with different masses being added to it. So it's quite a simple idea. We're going to delve into the maths quite deeply to look at how the deflection relates to the mass loaded on. So in essence, what we are doing then is we are changing our independent variable, in this instance, will be the masses applied. And of course, the fact that it has mass is not why that this is being deflected. It's the fact that the mass has weight. So we need to remind ourselves about that. 100-gram mass is actually 1 Newton. So in actual fact, we are looking at the load, which is a force, whereas the mass, which is measured in kilograms or grams, is actually the mass. Remembering that the load, or the weight, is mg. So if we had 100 grams, which is the same as dividing it by 1,000, making it 0.1 kilograms, multiply that by the gravitational field strength on Earth, it's approximately 1 Newton. Do the sums and make sure that that comes out correctly. So that's our independent variable, the mass, or more precisely the load that we're applying, and our dependent variable, that which we are measuring, will be the deflection, or as we called it in this experiment, the sag. And it's going to be in a distance. We're looking at millimeters because we know it's not going to be much. Let me place on 1, 2, 3, 4, 5, 6, 700 grams, 7 newtons, and we look at the deflection. Not much, hence we're going to measure it in millimeters. Good. How are we measuring the deflection? In other words, the position from where it was to where it is with the load on. We're going to measure it with a meter ruler. So it's quite straightforward to place a meter ruler there. However, it's very hard to find out where the position was originally, and so therefore the deflection. So we're going to need to take 2 readings in this case. One will be where it is without the load. In this case, well, we can either rate the top or the bottom, so long as we're being consistent. Let's say 63.2 in this instance, 63.2 centimeters. And then when we apply the load, I'm just putting 7 just for argument's sake here, and we've come down to 66 centimeters. Sorry, 65.6. Then the difference between them will give us our sag. And the difference between that is, let's quickly do the sums, 8, so it's 1.8 plus 0.6, 1.8 plus 0.6, 2.4 centimeters. So that's how we're going to go about it, loading from, actually we're going to load from about half, 1, 1.5, 2, 2.5, 3, 3.5, etc. newtons. So, nice and simply, looking at how load affects sag. Now, the other thing we need to bear in mind is what are we keeping constant in this experiment, or what other factors might affect it? The distance between. If I were to move it further apart, then for the same weight, we're probably going to sag further. So that's a control variable, how far apart these are. We've actually measured them off. We're looking to keep it at about 60 centimeters. Also where we hang the weight. I mean, we've measured it off, but we need to make sure that's at halfway too. We need to make sure the ruler's or the bit of wood's the same. And also what we need to make sure is that we're not just applying. Okay, so those are the things that we need to consider. We need to obviously make a table of results. Well, the table of results has actually been made for you. We are looking at, let me just remove this, with that. The table of results has been given on your sheet of paper, and it's asking to look at the mass, the load, the height, without and with, and therefore the sag. Repeat the readings once and see what happens. Now, I've made one earlier, as they say, and there are, should I say, the results. So we have our mass, our load, which we worked out by merely multiplying by 9.81, or 10. We took without the load, it looks like there was no warping of the wood, so it all started from the original position. With the load, and therefore the difference gave us the sag. Repeat it again, and it gave us the sag. So if you want to copy those down, hit pause, copy them down. There is one last column, which will be the average of these two. And that's important because that is one we're going to plot a graph with. So if you've got those results, then what we need to do is look at how we're going to plot the graph. With all graphs, we're looking to make the y-axis the dependent variable and the x-axis the independent variable. So x-axis independent, what did we vary? We varied the load in newtons, and what did we measure? We measured the sag in millimeters. And then we're looking just merely to plot the points and see what we come out with. Now, having done this before, I know that it's going to be a straight line. In actual fact, it's directly proportional. And what does that mean in effect? Well, it means it's a straight line and it's through the origin. That means directly proportional. It meant, in effect, if I doubled the load, so as I took a load, which gave me an extension, if I were to double that load, my sag rather than extension, sorry, my sag would be double. So plot the points and see what you come out with. And then I will, in another video, look at our ways of analyzing this, because there are 3 ways we're going to analyze it.